Assalamualaikum warahmatullahi wabarakatuh, and every good day to everybody. So now we move to our new chapter, chapter number 6, structure analysis. So in this chapter we have two main objectives. First one, we have this to determine the force in the member of truss using the method of join, and the second one is to analyze force acting on the member of frame and machine composed of pin connected members. So first one, we have the outline. We have three subtopics in this chapter. First one, simple trusses. Second one, the method of join. The third one is a frame and machine. So basically, what be the simple trusses? The truss composed of a slender members joined together at their end point. So you can see here, we have the slender member here at this end of here, end of join here, end of point here, and the members will be joined together. The planar trusses used to support a roof and bridge. This one is called the planar trusses. So roof load is transmitted to the truss. So all is called a truss, and joined by means a series of purlins. So we have we set this one, the set of our planar trusses, and then this one a series of transmitted. So all is transmitted by using this purlin here. Okay. So planar trusses, the analysis of the forces developed in truss member of 2D. So now we are focused on 2D dimension. So similar the roof truss, the bridge truss loading also in coplanar. So we have here is the roof truss, this one the bridge truss. So all the forces acting on their end joint here. Okay, so now what will be the assumption for our design? So all loading are applied at the joint. So all the loadings is applied at the joint. So the member of the weight of the member is neglected. So we are actually we didn't take care much about the weight, but we are taking more the how we want to join here, the type of joint, what be the force of joint of the member. So the member are joined together with smooth pin here. So assume connection provided the center line of the joint members are concurrent. So meaning that all the forces here will be applied on the concurrently at all the joining member. Okay. So the simple trusses, the form of truss must be rigid to prevent the collapse. This one is the purpose of the trusses, must be rigid to prevent the collapse. The simplest form that is rigid or stable is triangle. This one, the very basic simplest form of the rigid and stable is a triangle. Here you can see here, this one is not a triangle. This one is like they have a 1, 2, 3, 4, 5 members. This one just a simpler forces. But here, if you put another member, is actually I think is not very affected. If you didn't put the member AD and BC is not expected, because this one is when you apply the force to point C here, the load is distributed into all the member AC and BC. So that's why the triangle is the very simplest form that is rigid and stable enough. Okay. So we have to back to our objective. We determine the force member using the method of join. So we need to really understand what be the method of join. So we need to analyze, for example, this case, we want to find the member of the forces AB, BC, and AC, as well the support reaction here, the joint, hinge joint, and rocker joint, for example, if E and C here. So how you want to determine all the member forces? For truss, we need to know the force in each member. Force in the member are internal force. For external force, equation of equilibrium can be applied. You see here, you can see here 500 Newton here. We can see support reaction at E, support reaction at C. So we are again using the equation of equilibrium. So all the external and the support reaction are using the equation of equilibrium. But for the internal forces, for the force in the member, we are using the method of joint. Okay. Force system acting at each point is coplanar and concurrent. Coplanar, they have the two dimension X and Y, coplanar forces, and concurrent is the together. So in the equilibrium, so when we want to mean, because we are assuming all our our truss or our roof, for example, our bridge, for example, this one equilibrium. So because we want to make all these ones equilibrium, so meaning that each of joint must be equilibrium in order to complete all the whole of the trusses in equilibrium, to be all its joints must be in equilibrium. So in each joint, the method of joint, we can satisfy the equilibrium by using these two equations: total summation force in x component equal to 0 and total force component y direction equal to 0. Okay, so the procedure of analysis, we need to draw the free body diagram at each joint, at least one known and two unknown forces. Okay, and then find the external reaction at the truss support. If you have more than two unknown, so we can't proceed at that particular joint, so we need to move another joint. So if you have at least one known and two unknown, we can solve the equation. You can find the two unknown. Okay, so find the external reaction at the truss support. This one by using the equation of equilibrium. Determine the correct sense of the member, either it's a pulling or it's a tension or the compression. So orient the x and y axis. We need to reference our reference base in the origin x and y axis. So apply the equation of equilibrium. So total force in x component equal to 0, total force in y component equal to 0, and use known force to analyze the unknown forces. So we need to use the known forces to analyze the unknown forces. Okay, I think we stop here for this chapter. We will continue in our next video for the example for the method of joint, and also another example, another last video for this topic is for the frame dimension. Okay, see you again in the next video. Bye bye.